Pluto was reclassified from a planet to a dwarf planet by the International Astronomical Union, IAU, in 2006, a decision that marked the end of a long controversy about its status. This change mainly happened due to stricter criteria set for classifying celestial bodies as planets. According to the IAU, to be considered a planet, a celestial body must orbit the Sun, be spherical due to its own gravity, and have cleared its orbit of other debris. Pluto meets the first two criteria, but fails the last one. Its orbit is shared with other objects in the Kuiper Belt, a region filled with other icy bodies. Pluto's orbit also contributed to its reclassification. It's highly inclined and eccentric, differing significantly from the typical circular and aligned orbits of planets, where most planets orbit. These characteristics, along with the discoveries of other similar-sized or even larger objects than Pluto in the Kuiper Belt, such as Eris, led astronomers to question whether Pluto should indeed be considered a planet. These factors culminated in the IAU's decision to create a new category called dwarf planets, in which Pluto was included, acknowledging its significance while distinguishing its unique nature among the celestial bodies of the solar system. Located at the outer edges of our solar system, Pluto continues to fascinate scientists and astronomers with its peculiarities and mysteries. Come rediscover this fascinating planet with us. Methane storms on Pluto represent a fascinating and complex phenomenon in the study of celestial bodies in our solar system. Despite its distance from the Sun and extremely cold environment, Pluto maintains a tenuous atmosphere, predominantly composed of nitrogen, with traces of methane and carbon monoxide. This atmospheric composition is crucial for the occurrence of methane storms. During the approach of NASA's New Horizons spacecraft in 2015, detailed observations of these storms were made, providing unprecedented insights into the atmospheric dynamics of the dwarf planet. The dynamics of these storms are intriguing due to Pluto's unique conditions. The low temperatures, which can reach about -230 degrees Celsius, allow methane, which would be gaseous under warmer conditions, to condense and actively participate in the planet's meteorological cycles. During specific periods when Pluto gets closer to the Sun in its elliptical orbit, its atmosphere heats up enough for methane to freeze and then sublime, creating atmospheric movements and potentially generating observed storms. This process is similar, albeit much more extreme, to the water cycle on Earth, demonstrating how even the most distant celestial bodies have dynamic weather systems. In addition to its scientific implications, the study of methane storms on Pluto also highlights the capability of modern space technology. The New Horizons mission, by providing detailed data on these storms, not only expanded our knowledge about Pluto, but also about weather conditions in extremely cold and low-pressure environments. Could a body so distant from the Sun and seemingly inhospitable maintain water in a liquid state? The possibility of Pluto harboring a subsurface ocean beneath its frozen surface is a fascinating discovery that challenges our understanding of celestial bodies in the solar system. Some scientists suggest that this ocean is not only present, but may be kept in a liquid state due to heat generated within the dwarf planet's interior. This internal heat would result from the decay of radioactive elements, a process known as radioactive decay, which releases energy over time. This mechanism is similar to what is observed in other celestial bodies that have internal geological activity, such as Earth. Models suggesting the existence of a subsurface ocean on Pluto indicate that liquid water may be located between a thick layer of surface ice and a deeper rocky core. The presence of liquid water implies a series of internal dynamic processes that may influence the formation of geological features observed on Pluto's surface, such as icy plains and mountains. Furthermore, the idea of a subsurface ocean raises discussions about Pluto's potential habitability, as liquid water is a crucial element for life as we know it. The existence of this ocean suggests that Pluto could have an extremely effective insulating layer of ice in retaining internal heat, a phenomenon that challenges our expectations about heat transfer in dwarf planets. The idea that Pluto may have rings gained momentum after observations of stellar occultations, a phenomenon in which Pluto passes in front of a star and blocks its light. These occultations not only measure the size and shape of Pluto, but can also reveal the presence of surrounding material, such as dust rings or ice particles, similar to Jupiter and Saturn. During some of these occultations, anomalies in how the starlight was obscured were recorded, suggesting the presence of tenuous structures around the dwarf planet. Scientifically, the possibility of rings around Pluto is supported by the behavior of its 5 known moons and the dynamic interaction between them and the interplanetary medium. Planetary rings are typically formed by material ejected from moons or through the capture of interplanetary particles. In Pluto's case, it is believed that collisions between particles ejected from its moons, especially Charon, the largest one, may contribute to the formation of a ring system. Additionally, Pluto's low gravity and its exotic atmosphere, primarily composed of nitrogen, methane, and carbon monoxide, may facilitate the accumulation and stabilization of these particles around the dwarf planet. Interestingly, the exploration of Pluto by NASA's New Horizons spacecraft in 2015 provided valuable insights, but did not directly confirm the presence of rings. The images and data collected by the spacecraft did not show clear evidence of rings, but the limitation in image resolution and viewing angles may have obscured finer structures. The discovery of rings around Pluto would not only expand our understanding of the diversity and complexity of planetary systems, but also of the processes of ring formation in extreme conditions, far from the direct heat and gravitational influence of the Sun. During the flyby of NASA's New Horizons spacecraft in 2015, an interesting discovery was made: a blue sky. This intriguing discovery is due to the way sunlight is scattered by Pluto's extremely tenuous atmosphere. Just like on Earth, where nitrogen molecules and other particles scatter sunlight, on Pluto, tiny particles in the atmosphere, known as tholins, are responsible for this phenomenon. Tholins are complex macromolecules formed by the interaction of atmospheric gases with the Sun's ultraviolet radiation, and they predominantly scatter blue wavelength light, giving the sky its characteristic hue. The scattering of light that gives Pluto's sky its blue color occurs in a specifically termed Rayleigh scattering, the same as on Earth. However, Pluto's atmosphere is mainly composed of nitrogen, with traces of methane and carbon monoxide, which differs significantly from Earth's atmospheric composition. The extremely low density of the Plutonian atmosphere, combined with the dwarf planet's low gravity, allows these tholin particles to remain suspended in the atmosphere, contributing to the scattering effect. This is particularly fascinating because it indicates that complex atmospheric processes occur even on small and distant celestial bodies like Pluto. Interestingly, the blue color of the sky may not be a constant phenomenon on Pluto due to the extreme seasonal variation of the dwarf planet, which has a highly elliptical orbit and an extremely inclined axis of rotation. This results in significant variations in the atmosphere, including atmospheric pressure and chemical composition over its year, which lasts 248 Earth years. Seasonal changes may alter the visibility and intensity of the blue color in the sky, offering a dynamic atmospheric spectacle that challenges our understanding of climatic processes on cold and distant celestial bodies. Known for its unique geological features and exotic atmosphere, Pluto surprised the scientific community with the discovery of dunes on its surface. However, these dunes are not formed by sand, like those found in terrestrial deserts or even on Mars. Instead, they are composed of solid methane grains, a discovery made by NASA's New Horizons mission in 2018. Methane, which on Earth is a gas found mainly in the atmosphere, exists in a solid state in Pluto's extremely cold conditions, which reach about -230 degrees Celsius. The presence of these dunes indicates active geological processes, driven by a volatile material cycle similar to Earth's water cycle but dominated by nitrogen, methane, and carbon monoxide. The formation of these dunes is an intriguing phenomenon given that Pluto's atmosphere is incredibly tenuous, with a surface pressure that is only about 1/millionth of Earth's atmospheric pressure. Dune formation typically requires substantial winds to transport and deposit grains. However, studies indicate that even light winds, which can occur on Pluto's surface, are sufficient to move methane grains due to the dwarf planet's low gravity. Research suggests that these dunes primarily form by sublimating nitrogen ice on the plains, releasing gases that, upon condensation, deposit solidified methane, which is then distributed by Pluto's gentle winds. Despite its reclassification, Pluto has not lost its importance to science. With an icy surface and a solid nitrogen heart, it challenges our notions of what it means to be a celestial body in the cold vacuum of space. We hope you enjoyed exploring the mysteries and curiosities of Pluto with us. If you liked the video, don't forget to leave a like and subscribe to the channel for more content like this. Have any questions or want to share something interesting about Pluto? Leave your comment below. We'd love to read your thoughts and answer any questions. Until the next video, explore the stars and stay curious. If you enjoy exploring and studying the various places in the universe, you can't miss our new video. We delve into details about why Titan, Saturn's intriguing moon, may be a better option for colonization than Mars. Discover the environmental advantages, natural resources, and scientific potential that make Titan such a promising destination for humanity's future in space. Join us to unravel the mysteries and possibilities that Titan offers. Watch now and be part of this interplanetary journey. Goodbye, and see you later.